Downy mildew, primarily caused by the Yamacite Plasmopora viticola, was first identified on wild vines in the US in 1834 before devastating European vineyards in the 1870s. Introduced via American rootstocks, it caused a massive rapid pandemic. The first effective control, the Mildew mixture, was developed in 1885. Key historical milestones. 1834. P. viticola was first observed on Vitis aestivalis in the southern United States. 1870s. The pathogen was introduced to Europe, first detected in France in 1878 through imported American vine species brought in to combat phylloxera. 1880s. The disease spread rapidly across Europe, devastating the wine industry by destroying up to 50% of production. 1882 to 1885, Pierre-Marie Alexis Millardet discovered the antifungal properties of copper sulfate, leading to the invention of the Bordeaux mixture remains a key, though often criticized, treatment.
Mildew shows up first as pale or yellow splotches on top of leaves. And when it's dumped out, you'll spot fuzzy spore growth underneath. It's almost like a soft coating. Over time, those spots can turn brown and die off, and the whole plant might end up stunted or weak. It acts differently depending on what's infecting too. Cucumbers get sharp-edged angular spots, grapes develop weird oil spots, onions get purplish lesions, and purple Malay can even grow twisted leafy green ears instead of normal grain. Before you know it, in cool, humid weather, it can spread fast enough to take out whole plants or even entire patches of crops. Downy mildew is caused by specific Umacite pathogen, which is not true fungi, from genera like Plasmopora, Perennispora, and Bremia, each targeting particular plants. These pathogens survive through winter in infected debris, soil, perennial host, or even on seeds and transplants, then spread far and wide via wind currents, splashing rain, or irrigation water, and contact with infected tools or hands, thriving best when temperatures stay mild and humidity climbs over 85%. Especially with prolonged leaf wetness from dew, overhead watering, dense plantings, shaded spots, and poor airflow make conditions even more perfect for infection. While susceptible varieties and plants weakened by poor soil, nutrient gaps, or drought are far more vulnerable to severe attacks that can quickly take hold and spread through entire crops if conditions remain favorable. Downy mildew, which is caused by umicides, damages stems, flowers, leaves, fruits, which cuts down photosynthesis and overall yield. It can also spread systematically in some plants, like broccoli, stunt seedlings enough to lower field density, which reduces leaf wax in crops such as peas, making them more herbicide sensitive and weaken their winter hardiness in plants, like grapes, with moist conditions favoring spore spread and severe outbreaks potentially devastating entire crops if left unmanaged.
Mildew spreads through the air via tiny invisible spores carried by wind to nearby or distant plants. Via water when rain or overhead watering splashes spores from infected to healthy leaves, especially in crowded plantings, and by contact when touching infected plants or using dirty tools, transfers spores to healthy ones.
Mildew is a fungal disease that affects many kinds of plants. It attacks vegetables like cucumber, squash, melon, tomato, and lettuce. It can also affect fruits such as grapes and apples and flowers like roses and lilacs. Mildew has characteristics that make it easy to recognize. Powdery mildew looks like white or gray powder on the leaves and almost look like flour. And downy mildew shows yellow spots on the leaf itself.
Practical techniques for proper plant spacing and pruning to improve air circulations and reduce humidity around plants. Drip irrigation and morning watering help keep leaves dry, eliminating the moisture that promotes the pathogen's growth. removing any infected plant debris and disinfecting tools significantly reduce the number of pathogens present in the environment and prevent cross-contamination. The last line of Downy mildew prevention is proactive monitoring and early intervention. Unfortunately, treatments that depend solely on physical field checks frequently arrive far too late to avoid severe crop damage. Alternatively, the disease risk feature in our satellite crop monitoring solution can alert farmers to impending outbreaks by integrating weather predictions with data on plant growth stages. This enables crop producers to take proactive steps against the disease before it causes damage.
Treat powdery and downy mildew using targeted, regular, and repeated applications of organic or chemical fungicides, focusing on treating both sides of the leaves, pruning affected parts, and improving air circulation. Key treatments include potassium bicarbonate, sulfur sprays, neem oil, or homemade solutions like milk or baking soda. Effective treatments for mildew. Potassium bicarbonate. Mix 1 tablespoon potassium bicarbonate and 1/2 teaspoon liquid soap in 1 gallon of water. Apply to all affected areas for strong control. Sulfur/copper fungicides. Use sulfur-containing organic fungicides for existing infections. Copper fungicides can be used but require careful application to avoid plant damage. Neem oil. Apply neem oil to kill spores and prevent germination, ideally weekly. Milk spray. Mix 1 part milk with 2 to 3 parts water and apply in sunlight to create an inhospitable environment for fungi. Baking soda solution. Mix 1 tablespoon baking soda and 1/2 teaspoon liquid soap, not detergent, in 1 gallon of water. While better for prevention, it reduces the spread of existing mildew. Vinegar spray. Mix 4 tablespoon vinegar with 1 gallon of water, reapplying every 3 days. Control actions. Critical control actions. Pruning. Immediately cut off heavily infected leaves and stems to reduce spore load, ensuring tools are disinfected afterward. Disposal. Do not compost infected material. Destroy or discard it. Application tips. Spray thoroughly on both the top and bottom of leaves, as fungicides need direct contact with the fungus. Environment control. Improve air circulation through thinning and avoid overhead watering to reduce humidity.